Good morning, everybody that's joining us today for our AI and LLMs webinar for nonprofits. So there's no doubt that this is a super hot topic at the moment, and there is a huge amount of information being shared. So it can be difficult to know where to start or what to do with it all. So we're really hoping that today we can provide some clarity in a fun and engaging way on the considerations and the opportunities for nonprofits with AI and LLMs. So for those of you new to Torchbox and our webinars, I'm Lisa and I'm head of marketing, and I help to plan and launch these events for nonprofits. And your speakers today are Ed Baldry, our Director of Innovation, and Andy Gordon, our Senior Innovation Designer. And Andy and Ed both have a huge amount of experience in tech and innovation design for nonprofits and commercial organizations, including Google and the United Nations and Macmillan. And just a bit of housekeeping before I hand over. So this is a webinar, so you can see us, but we can't see you. But we would love it to be interactive. So if you've got questions, which I'm sure you will have, if you can put them in the Q&A, we'll answer some as we go by typing, and then some of them we'll answer live at the end. So you should get a notification if we're going to answer it at the end. We're not ignoring you, but please use the chat for your comments as well. And I am recording the session so that I can share it with you after. And you should be able to enable live script from the navigation if you need to as well. And I'm going to be sending a follow-up email to you after as well with the recording, but also with links to any of the sites and resources that we've referenced in the presentation as well. And I think that's all from me. So I will now hand you over to Ed.
Perfect. Thanks, Lisa. And super exciting to see so many people here. Cool. This is a filled hour of entertainment and hopefully knowledge. So in the next hour, we're going to be covering, Andy will be covering, why is AI such a hot topic? I'm going to be talking about how generative AI works and then why it's useful from the way that it's working. Some of the experiments that we've been doing, both internally and externally with our clients, and then what others are doing that Andy's going to be covering, and then Andy and I will be running through what you can do to actually take some actions away from this webinar. With that, I'm going to hand over to Andy, who'll be starting off with why AI is such a hot topic.
Thank you very much, Ed. I'm really excited to be talking to you all today about artificial intelligence, but no doubt it's a hot topic. We've personally seen it come up everywhere from barbecues to agenda points in a boardroom. But whenever we say artificial intelligence, I'd love to just, in the chat, for you to share what that means to you, what you're feeling about artificial intelligence. There's no wrong or right answer, so please, we just love to hear your thoughts whenever we say that word. Very quiet. One word for AI.
Webinar, no one's warmed up. I know some are coming through.
Excited, apprehensive, scared, possibilities, optimistic, intrigued. We'll have to embrace it. Yeah, absolutely. And it's absolutely no wonder why, right? We're seeing headlines from industry leaders asking for a giant pause on any further development of some AI systems due to safety concerns. We've seen headlines around countries like Italy, where it is, banning ChatGPT. I've lost count at the number of articles I've read around AI potentially replacing millions of jobs. There's been headlines around national security risks, bad actors getting hold of artificial intelligence, whether that's for scams or debt collecting. Some nonprofits coming under fire to the use of AI-generated images. And there's been a heck of a lot of news more recently on AI regulation and governance. So there's no doubt that that's probably evoking a lot of kind of more negative emotions. But, and again, alluding to a lot of what's been in the chat, there's a lot of positive headlines of artificial intelligence as well. So from scientists being able to use artificial intelligence to detect infant blindness, to organizations like Climate Cardinals being able to accelerate climate translation and information, scientists being able to identify antibiotics discovered by AI, Microsoft releasing a number of different tools and solutions to kind of absolutely change the fundraising and volunteer game, being able to predict rare diseases, and finally as a tool to help us tackle the climate crisis and some of the problems with our triple planetary crisis. So there's no doubt that you're probably feeling a lot of positive emotions when I shared some of those stories. And together that's a heck of a lot. And there's a lot of ambiguity and potentially uncertainty. The pace of change is like nothing I've ever experienced before. It's changing daily. I even had to update this presentation this morning based on something that I read. And naturally that, again, as I mentioned, fills us with a lot of ambiguity and potential uncertainty. But AI has been around for almost 70 years. It's definitely not new. So computer scientist John McCarthy coined the term artificial intelligence. He was a computer scientist and was one of the founding fathers of artificial intelligence, along with people like Alan Turing. And the definition that he coined was the science and engineering of making intelligent machines. So if we think about that and that term and the way that that's been described, we've had artificial intelligence in our lives for a long time, spanning both physical and digital worlds. We've had it in our traffic lights. So they were able to sense the speed of oncoming vehicles, analyze emergency service data, and then adjust their timings accordingly. A modern washing machine uses artificial intelligence to be able to sense the weight of the load and adjust things like detergent and timings accordingly. Google Maps, we probably all use Google Maps at some point or another, but that helps us get from A to B, taking into consideration live data, and things like congestion, road closure, and even our environmental impact. And then entertainment companies like Netflix or Spotify are using artificial intelligence to learn from your behaviors and provide you with a personalized experience. Or if you're still logged in at your parents-in-law's, you get a lot of Justin Bieber suggestions. For me, far from ideal. In some way or another, they're all powered by some form of artificial intelligence. So why has there been a sudden influx of AI news? We're seeing it absolutely everywhere. A type of generative AI called large language models, or LLMs. As many of you here will be aware, OpenAI released ChatGPT in November last year, and that essentially made large language models accessible to the general public, providing they signed up, and they were then able to interact with those large language models. Ed's going to go into exactly what they are in a moment. But before he does, I'm going to talk a little bit about why that was such a monumental point in time. The ChatGPT in particular was the fastest tech adoption in history. So to get to 1 million users, it took 5 days, and 100 million took 2 months. If you compare that to something like Facebook, it took Facebook 4 years or over 4 years to get to 100 million users, and Instagram took nearly 2.5. We've seen reports coming from MIT and NVIDIA promising 50% productivity increases. And again, if you compare that to things like the internet, that's 10% productivity increases. Steam power was 25 and electricity was 35. And more importantly, it offers us completely new possibilities to accelerate change, how we communicate, how we work, and how we do things. But ChatGPT isn't the only tool. There's been many before and there's been many after, some open source, some more responsible, like Anthropic's Claude, some just nowhere near as good, like Google Bard. I'm going to pass across now to Ed to talk a little bit about what large language models are.
Cool, thanks, Andy. Better check I'm not on mute. Good, I'm talking. Great. So what are large language models? large language models are a bit confusing, right? In so much as they process, understand, and generate tokens. And as human beings, we don't really think in, well, we don't think in tokens at all. We're not computers, we're not machines. A token's be used in two ways from a large language model perspective. They can either generate text or they can generate images. And both of these things are potentially very useful for us. But I'm going to start off with explaining them from the perspective of text. And most of what I'll be talking about will be from a text-based perspective because it's slightly easier to explain, I think. So let's take a fairly famous stub of an expression, to be or not to be. Now, I suspect everybody on this webinar has already completed this sentence in their head, right? We know that, you know, that is the question, and then it will keep going. And hopefully, well, I had to double check that it was Hamlet rather than Macbeth, but for others who are paying more attention, they know where it's come from. But as humans, we know how to complete it because we've heard the sentence many times before. Now, a machine, a large language model, has to do something slightly different. So what it does is it evaluates the initial bit of the sentence, the tokens that are there, and a token roughly correlates to a word. Not always, but more or less roughly correlates to a word. And it then thinks about the probability of the next word that it needs to put in there. And so it's a bit like how we talk in sentences when we're talking to other human beings, right? We put one sentence after the other, and we hope by the end of the sentence has made sense to the people we talk to. And large language models are doing that the whole time. Now, interestingly, the probability is not set in stone, as in the large language model will not always use the highest probability token. If it does that, it starts to create weird and wonky sentences. So here it's decided to use sentiment rather than something else. And this all feels like magic. I mean, it really does. Like, I don't know for people who had their first interaction with large language models, but certainly for mine, it feels like magic. And it sort of is like magic to the extent that magic is where we don't quite understand what has happened. And there's a bit of a surprise and it's fooling, not in a bad way, but it's, there are some mysteries around how it is operating. I'm going to try and make some of those mysteries a little bit clearer here by explaining what is happening when large language models are working. So the first step in any large language model is around data collection. Now, data collection isn't something that is new here. I've got three of the biggest examples here: Common Crawl, Web Text, and Book Corpus. And they've been going for years. Common Crawl started in 2011, Web Text was 2008, and Book Corpus is 2005. And they're all doing slightly different things. Common Crawl essentially just crawls across the internet. Web Text is looking at Reddit, and any link that gets 3 or more votes is consumed. And Book Corpus is related to Google's book repository. You can imagine, especially thinking about Reddit and all the links that are in there, some of the content that is collected is suboptimal, which is a polite way of saying it can be awful, but it could also just be nonsensical, right? You find something that isn't actually in human language. It is literally nonsensical. And the people responsible for, well, they're not responsible, but the people who are at the center of cleaning this data are Google. So all of the large language models who have publicly put out the data they've been using have all been using the very pithy C4 rep set from Google, which is colossal clean crawled corpus, which is even more pithy than C4. I guess just to put in contrast the difference between the C4 dataset and the Common Crawl dataset, these are the top ranking data points within C4. So relatively trustworthy sources, right? We've got The Guardian there, we've got Huffington Post, New York Times, we've got Wikipedia. By contrast, Common Crawl is slightly less reliable, right? I'm not sure I'll trust something from free.fr or from sub.ru or even blogspot.com, right? I'm going to trust C4 over that. So C4 is doing good, important stuff. We've got our data is being cleaned, and now it's time to train our model. Now, a lot of people will talk about large language models being black boxes, and that is actually quite a fair definition of what's going on. We don't, and by we I mean humans, do not understand exactly what the neural networks in large language models are doing, because they don't behave in the way that we do. Machines consume content differently to humans. So I'm going to pause for a couple of seconds and just allow you to think about, this is step 10 in a 24 process of a computer trying to generate an image. I just try and think about what it might be trying to generate. Oh, someone's come with rabbit. Rabbit is a really popular one. It's not a rabbit, unfortunately. I sort of wish it was a rabbit. It's actually a cat. I think the most cat-like image is column 1, row 3, where you can sort of see the eyes and the nose and maybe just the pointy ears if you're looking carefully. But this clearly isn't, this isn't how humans think about a cat when they're thinking of drawing a cat. And likewise, when large language models, generative AI is thinking about text, definitely doesn't have any relationship to how we think about text. So the images here are the embedding vectors that GPT-3 used to visualize, or if you chose to visualize, these words as images, and clearly they're completely nonsensical to us as humans. And then underneath is again how GPT-3 put the word into a vector, which is a number. So cat is 9246, dog is 3290, and chair is 5118, which again, kind of completely nonsensical to us as humans. And so I think it's fair, just leave the box, close the box, and work on the basis that it's working and all is good. Before I move on from talking about the box though, I will mention the fact that unlike lots of other AI or machine learning tools that we've gotten used to over the years, large language models are static. They're trained at a certain point of time with a certain data set, and they can't then be improved upon without retraining the whole thing. So you need to metaphorically unpack the entire box, rearrange it, and then put it back in and close the lid. And that's a pretty big preconception that people have when they're interacting with GPT-4 or Bard or any of the other. It's not getting smarter from our interactions with it. It's just changing the top level context of the conversation that you're having with it. But cool. We're now at the point where we can make predictions, or if this was an image generator, it could start generating images. And from a training perspective, what it's trying to do is simulate human conversation. So it is put all of the words in proximity to one another. So this is a grossly simplified view of what it's doing, but nouns on one side, adverbs on the other. And what it's going to do is, based on probabilities, track between those different grammatical elements to produce a sentence that sounds, quote unquote, human. Which is all well and good, very smart, really intelligent, very clever, round of applause for the scientists, the engineers, and the humans that did this. Why is it useful? Well, the reason it's useful is because of the randomness. It's because we're basing things around probability rather than being deterministic and saying that it absolutely has to be this thing. So suddenly, machines can take 2 + 2, and they could potentially answer with the response 5. And this is really cool because when I put that sentence to be or not to be up on the screen, had I challenged people to think of other sentences starting with that stub, we'd have all found it really difficult, because humans, we like to think of ourselves as being super creative, but actually we're quite fixated on how we approach certain tasks, whether those are visual or whether those are creating content. And that weakness is something that large language models can support. And I think another way to look at this, humans are weak in another perspective. We're physically not that strong, especially compared to some other things in the world. But if there's a boulder in front of me and I need to shift it, I'm not going to be able to do that. I'm going to need to go and get a tool that will allow me to shift it. And I feel like I need to be transparent here and say that I double checked with a friend who's an engineer of whether I could actually move a boulder with a forklift truck, and he told me I was an idiot. So forklift trucks cannot move boulders, but hopefully therefore remains intact. That a forklift truck gives me superhuman powers, right? I can suddenly be the strongest human, or stronger than the strongest human on the planet by adopting this tool. It will augment what I can do. And in our world, when, you know, I'm working with clients, when I'm working with innovation, I've got lots of these metaphorical boulders in my way where it would be really useful to be able to augment my capabilities or the capabilities of my team or the teams that I'm working with. And just some of the boulders, I mean, there's not infinite boulders, but there are a lot of them, but just to run through some of them, you know, grant writing and fundraising is hard. Personalizing communications for donors is hard. Looking at new angles to solve problems, right, is, you know, laterally approaching things, thinking about things from the perspective of different domains. Hard. Analyzing data, it's annoying, it's boring. I would much rather be doing other things, but it's an integral part of my work. Hard can microcopy at people, talking about complex topics, simply communicating clearly with other human beings, and, you know, the drudge work of getting my stuff or getting client stuff or any other content into the digital realm. It's all hard, and it can all be helped with large language models, which is very cool. So there are 3 ways that we can use these tools to augment our capabilities. First, pretty simple. We can just interact directly with them, right? So if you haven't done this already, I would really encourage you to go and, you know, chat.openai.com, bard.google.com, go visit Anthropic's Bard, start having conversations with them. And we did initially, when we were starting this presentation, have a whole thing about how you could use chat.openai.com, and realized that was completely pointless, because ultimately, as I mentioned before, what large language models are doing is they are trying to simulate human conversations. So the best way to communicate with them is to have a human conversation. And actually, we created a little app 3 months ago around this, using anthropology, social science, communication theory, to talk about some principles that we felt would be really advantageous when people are approaching direct communication with large language models. That's great. Talking directly with a large language model is really useful for me. You know, if I'm as an individual contributor, let's say I need to synthesize some research, super helpful. You can plug it in, get the results, and put it into my report. It's less useful when you're thinking about yourself as part of a team, or when you're thinking about how your end users could use it. And in that scenario, you need to interact indirectly with a large language model. So we need to create an interface between us and the users, us and the large language model. And we can do this in a super simple way. I mean, a really incredibly simple way. We can literally just put a wrapper around what the user asks. So here we take a text input, have the prompt, we send that prompt to an API, whatever it is the user puts in, it goes to the large language model, and whatever the large language model comes back with, we show it to the user, right? Dead simple. We can also do it in a slightly more complex way. And this is what we've been doing with RNIB, where we use a vector database. So we take a whole bunch of different content, we synthesize that, and we place it in chunks, so 100-word, 200-word chunks into a vector database, so where there is a relationship between that content. When the input is put in by the user, we check the database. If content exists within the database, we then send it to the large language model, and whatever the large language model comes back with, we show it to the user. And as you can imagine, we've been doing quite a lot of experiments and projects around this sort of thing. So I'm just going to run through 4 really quickly. One of them is what we've been calling a content check. So one of the uses internally that we saw pretty early was, how can we improve communication with our clients, with ourselves? How can we make it easier for people to communicate clearly? I've used to be or not to be, that is the question. And apparently GPT-4 thinks there are only 2 changes required, which I was kind of surprised by, but 2 changes required to bring Shakespearean English into modern day English. And the tool, if you were to click the automatically apply these 2 suggestions, would, as the name suggests, apply it, give you back your text, and then you can go on with your day. The problem we were trying to solve here was, at the moment, GPT-4 would just rewrite your content. It's kind of like someone in a Word document not tracking their changes when they're editing your work. It's kind of hard to see what's happened. Another project interface we've been doing is in the slightly scary space, or in fact, the very scary space of the terminal. So terminal is important when we're thinking about development. because it's where developers do all of their work. And one of the things that's interesting about large language models is how they can augment the capabilities of non-domain specialists, right? So we created Margit to allow people to interface with Git. So you can use natural language to say, I want to do something with the files that I have. It will go to GPT-4. It will tell you the commands that you need to run. And then it will ask you, do you want to run the commands, yay or nay? And we're experimenting with, can that allow designers? Can that allow other innovators? Can that allow even potentially clients to interact with development environments? Another example, this is more complex, that we've been working on with RNIB, where we use vector database, where we've been using a vector database, and their helpline staff have been using it. They ask a question and they get from a bunch of internal knowledge a synthesized response that's about 100 words long. And it's very useful for them when they're on a phone call, because it's not overwhelming them with information. And if they do need to dig in to get more information, because it has been in a vector database, unlike if we were directly interfacing with a large language model, they get the sources. So because we've got this vector database, we can say, this information has come from these 4 places. Do you want to go and find out some more information from them? Finally, of the interface projects, the very bubble pink and very pithily named natural language BigQuery tool is something that we're experimenting with because of the universal analytics to GA4 change that is going on at the moment. And if you're not familiar with the universal analytics to GA4 stuff, get in touch with the digital marketing team, because they can talk about it in much more depth. But essentially, we now need to be able to communicate with BigQuery to get some data out of it. And so this, similarly to the tool talking to Git, allows someone to ask in natural language their question. It comes back in SQL. You then get the information of how much is this going to cost, because unfortunately, BigQuery has a cost associated with it. It's probably okay though, because I can run this 1.1 million times in a month without hitting my monthly allowance. And it gives us the response we're looking for, so it's all good. So this is great. Interfacing creates huge amounts of value, really beneficial, super cool. But there are dragons, unfortunately. One of the dragons is just an annoying dragon, and I'm not going to dig into too much detail because Andy's going to be covering some of this stuff later, but large language models can just come back with unhelpful content. You know, the classic kind of computer says no. The equivalent in large language models world, especially with OpenAI, is as a large language model, I cannot, etc., etc. It can also come back with unexpected content. If I, as a beginner, go and ask it something and it comes back talking to me as though I'm an expert, it's not going to be very helpful, and that will be unexpected. The final annoying dragon is there's an ongoing cost. Within the digital world, we've gotten used to not really having cost of goods as a consideration. With large language models, if we're interfacing with them, we need to consider that cost. The other dragon is a harmful dragon and is very bad news. So top of the list is misinformation. So the cute version of misinformation is that if you asked GPT-3 back in the day, what happened if you broke a mirror, it would very sweetly answer that you'd get 7 years bad luck, which is fun, right? It's funny. It's also kind of impressive because it's taken a wrong thinking human concept and translated it into the machine. But you can see pretty quickly how that becomes really bad really quickly about other subjects. The other problem is hateful speech. The data that has been ingested, despite being filtered, has really bad things in it, and they're quite easy to get back out of the large language model if you want to push it. And of course, hateful speech, the problem is the harm that it does to human beings, but it also has a reputational damage risk. It can harm organizations, it can harm projects that cause that pain. Finally, just to finish off, why interfacing might not be the greatest idea is this quote from Luciani, who works at Hugging Face. Hugging Face is right in the center of the large language model world. And he says that interfacing directly very often is like using a microscope to hammer in a nail. Sure, it's going to do what you want to do, but quite often that actually isn't the right tool for the job. So there's a third way that we think is interesting we've started experimenting with, and it's around embodiment. And we've borrowed this from climate science, right? When we think of life cycle analyses of cars or buildings or any of those sorts of things, you think about the carbon that has been embodied in that object at production. So to use electricity as an example, we don't want to interface directly with electricity, or at least it's pretty boring to interface directly with it, right? Solar panels, coal, they're all dull in terms of they don't produce anything of real value, and lightning is, you don't want to be in a lightning storm. The really cool thing about electricity is when you interface directly with it, you can do some remarkable things. We can have this phone call. You can have light after dark. The really cool thing about electricity and why it drove the second industrial revolution is that you can embody the energy from that electrical current, and you can create things. Everything on my desk, everything in the desks in front of you will have been produced by electricity. All the books you have, magazines, they all exist because there was a printing press that was running, and then it produced something that will outlast that original use of energy. And Andy talked about some of the advances, some of the productivity improvements we've seen from tech advances in the past. And, first industrial revolution, we had a 25% uptick, electricity 35% uptick in the second industrial revolution. And MIT researchers are suggesting it could be as much as 50% with the large language models. It comes with a heavy dose of salt. And actually, there's some more recent research that suggests it will be lower than that, but didn't update the slide deck in time to do that. We've already seen some of these productivity boosts, though. We can see that embodying these large language models can be really interesting. So we created this little product because which has 240 prompts to just get working software out of GPT-4 with really not very much information, right? If you for whatever reason want a Mario Kart bar chart web page, you can go and use this prompt and you'll get a working website that you can deploy to a server right now. More impressively, Tom Dyson, the CTO here at Torchbox, discovered that if he used an API specification that was well known to GPT-4, he could get a working application, a fully working thing that allowed you to send questions to a large language model and get responses back with this single prompt. So really interesting ways that you can speed up work. Outside of productivity, there's another reason why you want to embody the energy from large language models and then cut off the connection to LLMs. If you need 2 + 2 = 4, you can't use a large language model. I talked earlier about 2 + 2 could equal 5 in their world. There are lots of things in social innovation, charities, nonprofits, where actually we need to know, it's a true or false answer. Can't muck around. So we've been exploring this in a few different places. So the website we did in 2 days. We were using an unknown framework, very impressive, large language model, just, smashed through it. Equally, we demonstrated in a very silly app that we could pass natural language without needing a large language model, but using a large language model to do it. And this produces SVGs, and will also give you a bit of a spicy response if you try and jailbreak it, because it's a deterministic tool. So you can't jailbreak it. You can't get bad things out of it because there is no badness underneath the hood in the way there is with large language models. And the final one, before I do a quick recap and hand over to Andy, we did this AI future ready analysis, which has a scoring system and a benchmarking tool for people to figure out where they are in their journey to AI maturity. It's a super quick recap because I know that was an awful lot to take in. LLMs are valuable because they're random. They can augment our capabilities. So just like a forklift truck, they can augment our creativity, they can augment our productivity. We can interact with them in 3 ways: directly, indirectly by interfacing with them, or through embodying them into a product or service. And we strongly believe that it's the embodiment that is where the most interesting work can be done in the near future. With that, I'll hand back across to Andy, who can take you through the good and the bad of large language models.
Thank you very much, Ed. So this could easily be a whole webinar in itself, but I'm going to take you through some of the really important things that you need to know about large language models, some of the commercially led models in particular. I'm going to start with the bad, or some of the risks, should I say. We had a comment in the chat around AI being biased and potentially how to mitigate that, but large language models have been known to give biased and discriminating outputs. As Ed explained, the way that these work by scaling large data sets, so naturally, if there's any bias in that data set, combined with things like human bias and any potential underrepresented voices, the responses that you get are going to reflect that. Next is around misinformation. Again, Ed's touched on that, but if there's any potentially errors in training data, the fact that these are not deterministic, if there's any ambiguity around prompts and these machines don't understand context, you could potentially have incorrect or unreliable outputs. To give you a couple of examples of what that might look like, again, the top right is around a user asking for a Python function or code to check if someone's a good scientist based on their race and gender. You could argue that that's a bad prompt in itself, but the output is giving us that if they're white and male, that's true. If anything else is false, clearly that's hugely damaging. And also if that code was used going unchecked. Another is around the user asking for summaries of articles, in this case around Meg Wanzhou, who is at Huawei. And it's given 3 really confident, incredible references as a result, one from the New York Times, one from CBC, one from CNBC. If you clicked on any of these, they take you to a 404 page. They're completely made up. So they're not true. So it's something that we need to consider with large language models in particular. And there are ways to mitigate and overcome this, as Ed's discussed. The next is large language models have an environmental impact due to their computational costs. Everything from the European Commission to Stanford have done research into this. We don't have lots of data on actually the full life cycle, including things like hardware, but there are companies like Hugging Face exploring this. But what we have found, some of the estimates so far, is that to train some of these models, like ChatGPT 3.5, for example, it took the equivalent of you or I taking or the same carbon emissions as you or I taking 500 flights from San Francisco to New York. And the best estimates so far about using these tools, they're about 4 or 5 times that of using something like Google. The next is around misuse, copyright, and accountability. So like any technology, it's subject to potential bad actors, so people that are going to misuse the technology. This is just one example on the right-hand side. This is someone conversing with GPT 3.5 and asking how to rob a bank. Initially, it obviously talked about it being a serious crime, but when it's prompted further, it gives lots of further detail in terms of how you might do that, weapons, all that type of thing. So again, that can be potentially dangerous if we're interacting with language models. Another is around copyright. And again, this is how these large language models and image generators work. They're scouring people's original content and repurposing that in some way or form. There's numerous ongoing cases, particularly there's a couple in London, and court cases that are going to basically be the benchmark around accountability moving forward. That does beg the question and kind of offers us up at who is accountable. Naturally, organizations like Google, OpenAI, and Microsoft don't want that to be them. So we need to be really careful that that's not passed across to us. The next is around, again, focused on OpenAI this time, but there's been a couple of different journalists reporting on worker exploitation, so particularly around Kenyan workers being exploited for less than $2 an hour and being subject to quite horrific content to make their systems safer. Again, this is something that we need to know about whenever we're engaging with these principles. And the next is transparency concerns as well. So GPT-4 has been far from, OpenAI has been far from transparent about GPT-4 in particular, about how they've got their data. And this has raised a number of different privacy concerns. I added this slide this morning because actually there's now been talks about OpenAI, DeepMind and Anthropic actually opening up their models, which is a step in the right direction to the UK government. Again, they're not completely transparent. The next is around consolidation of power. This is by no means specific to large language models. This is AI more generally. By a few entities controlling power of artificial intelligence, we're not necessarily dispersing the benefits equally, and we're far from kind of everyone having equal influence. There's been a lot of headlines around robots taking over and potentially producing deadly weapons. These types of things, we're far from that. Humans are still in control, but these narratives are really obscuring some of the real risks that we've discussed already. All of these are potential reputational risks for non-profits and could lead to the erosion of trust. We need to be careful. There's absolutely ways to overcome many of these challenges, to mitigate them, scan for consequences, and creatively overcome them. But it's something that we need to consider as we're engaging with these models. The next is a little bit more positive. So Ed's talked about some of those boosting productivity. We've had everything from Stanford professors through to GitHub discussing around how these models are potentially going to completely transform productivity. We've seen this firsthand in many cases. So as Ed mentioned earlier, building a website, an absolute custom website in 2 days, to helping us with coding, to research. We've seen lots of productivity boosts across the board. We talked about machines and large language models making errors, but they can also help us reduce them. So everything from content checking to data analysis. We can use large language models in multiple different use cases to help reduce human error. Our days are filled with numerous monotonous and laborious tasks. There's plenty of things that I'd rather not be doing and could be focusing elsewhere for impact. Large language models can be used as a co-pilot for many of these. And there's also talks about automation. We believe that humans should be in the loop, but there are other AI systems that can potentially automate some of these. We've also been exploring large language models as a co-pilot to tackle really complex challenges. So Ed's been looking at how we can put a solar panel on every roof even, and I've been exploring how we might be able to use some of these large language models as a partner for systems innovation and systems change. The next, and you've probably seen a fair few articles on this, but we can use large language models to assist and increase fundraising efforts. Non-profits have been using AI systems for a while to do this, but there's everything from data analysis to grant writing. There's the potential to use these models in this space as well. All of this adds up potential costs and operational efficiencies. We've even been looking at what we call long tail problems, so problems that we just couldn't solve before, or potentially problems that just was too much effort to solve. Even some of the smallest operational efficiencies using large language models can save a lot of money and time. LLMs are an incredible tool for advanced data analysis and potential pattern spotting. This example on the left isn't using large language models, but we could see applications in terms of how they could be used in similar ways. It's from the World Food Programme using live data, analysing that through AI to be able to identify potential regions of food shortage. I'm going to go into a few more examples in a moment. And all of this ladders up to potentially being able to make faster, better decisions and improve organizational decision making. That's increasingly important given the complexity of challenges we're having to solve and the increased uncertainty that we're facing. Again, linking back to Ed's comment earlier about embodying these large language models and I think the metaphor of electricity, there's potentially completely new opportunity to reimagine how we do things today, how we work, the way that we can actually deliver impact. All of these feel a little bit intangible, so I'm going to take you through a few examples of non-profits using artificial intelligence for good. Here's a few inspiring examples. The first is the World Bee Project, and they've been using artificial intelligence to help bee populations not only survive, but thrive. They do this through Internet of Things sensors, so things like cameras, microphones, and other sensors on hives. They're able to use that live data and then analyze that through artificial intelligence and machine learning techniques to spot particular patterns that are emerging. And that then allows them to take numerous different actions to ensure that our bee populations thrive worldwide. The next is Cystic Fibrosis Trust. They're using AI to spot patterns in numerous, over 1,000 mutations of cystic fibrosis. The way that they're doing that is analyzing critical cystic fibrosis medical data, again, using AI systems to spot and learn behaviors, symptoms, treatments. And that allows them to diagnose the different mutations better and provide tailored treatment for those specific mutations. Greenpeace has been using artificial intelligence, particularly in the fundraising space. This was Greenpeace Australia. So what they did was look at their entire history of fundraising data. They used AI to identify deep patterns in that data and assign a donor propensity score. So that's basically a probability of giving. That gave them an output of list of donors most likely to give and also help them reduce churn. I love this example. So this is Girl Effect. It won a Fastco Design Award last year, but they created an AI-powered agony aunt called Big Sis, allowing girls in South Africa to ask delicate questions that they just wouldn't ask otherwise. So the way that this works is the girls are able to interact with Big Sis, a chatbot. AI responds with advice from experts that have been vetted by the Global Digital Health Forum. And in return, those individuals are able to get engaging, immediate answers to these questions and recommendations of experts to speak to in particular cases. And finally, we'll talk a little bit about Earth Species Project. So this is quite different, using the same principles of large language models, but they're trying to understand non-human language, so animals and our natural ecosystems, to advance conservation efforts. So they're getting data from numerous different sources like bioacoustics and satellite. They're able to process that and analyze it using artificial intelligence. And then that leads to action and conservation efforts across the board. So those are some really inspiring examples I hopefully brought to life artificial intelligence being used by nonprofits and purpose-led organizations. But what can you do today? The first is going to sound really simple, but it's around choosing a model that aligns with you and engaging with that today. We've learned an incredible amount by just playing with these different models, learning about their capabilities, what they're good at, their downsides, and then that's helped us identify potential use cases and problems that we might be able to solve. But that's trialing and playing with these AI tools. The next is around learning through making, so exploring through building and learning. So, as Ed mentioned, we've created a number, well, we've done, I think, over hundreds of experiments in the AI space, and particularly focused on large language models. We've built tools, we've built solutions to problems, and actually through that, we've learned an incredible amount. And so we've been able to build internal capabilities through our experiments. Ed's touched on this, and it's definitely our advice. It's around embodying and not interfacing. By interfacing, obviously, we've covered quite a few of the risks, but by embodying large language models, we can reimagine possibility. This ladders up to building a more responsible culture of AI innovation, which we think is integral for nonprofits. And finally, it's around staying deeply focused on real problems. That's the people you serve, the organizations, so the people you serve, the people inside your organizations, but by ensuring people are at the heart. we're able to assess different use cases much better and ensure that these large language models are used for good. I'm now going to pass across to Ed and talk a little bit about how we can support you.
Cool. I'm conscious of time and there's a few good questions to get through. So very briefly, 30-second sales pitch of the innovation team. There are 3 layers to engaging with innovation in the realm of the era of AI, as people are calling it. One, strategy. So it's thinking about what the governance framework is, what your ethics are, all of those pieces. And we have several workshops we can run through with that. The other is acceleration. So thinking about how we can use 1-day sprints, 5-day sprints, 10-day sprints to really get something that's valuable and is usable, testable to validate learning. And finally, there's culture. So it's empowering people to feel confident with new tools, new ways of working, and how it can integrate into our everyday. And if you're interested, there is a specific website for AI and innovation at Torchbox at ai.torchbox.com, which Lisa will send to everybody afterwards. You find some resources, you find lots of chat around dangers of large language models, generative AI, glossaries of some of the stuff that doesn't make any sense, more information about our services, and links across to projects that we've been working on. But with that, I think we can move handily to questions.
Oh, yeah, brilliant. Thank you. Do you want to stop sharing, Ed, as well? And then we can all see you. We've got some really good questions. So we've got a bit of time left, which is fab. So one of the ones, I know you touched on it in terms of the bias discussion. And so one of the questions is, one of the benefits of AI is that it can be more bias-free than humans. But what if the data is trained on is inherently biased? And how can we as humans stop that and improve that? So I know you touched on it, but it's probably more to discuss.
Yeah, I think there's it's a really hard problem to solve, right? Because it's being trained on human content, it is very hard to get human bias out of it. So there's 3 ways that it can introduce bias. There's human falsehood. So I use the 7 years of bad luck piece, right? That's just wrong, but very hard to remove. There's then human inaccuracies, which I guess is the polite way of well, some of them are literal inaccuracies, right? But lots of them are purely hateful in terms of their thinking, but lots of humans hold them. The other problem with large language models, and this relates to the fact that it's always a static box, it's always going to be outdated or limited, or at least until that problem has been solved, the data is always going to be limited in some way. So yeah, it's a real challenge. It's one of the reasons why interfacing directly with large language models carries the risk that it does.
Thank you, Ed. Do you want to expand on that at all, Andy, or anything in relation to Barney's point as well around this?
No, I think what Ed's mentioned is it's really difficult challenge. We're actually writing an article as we speak on some of the mitigation techniques in terms of what people can actually do. So we'll share that. I think it's such a big topic, but it's around the diverse training sets, that we'll never be able to potentially completely eliminate that bias. Also things like safety checks and always checking the output is a huge step that we all can individually take.
Okay, fab. If you signed up to our newsletter when you were registering, you'll get all this new content as it comes out as well. So the second question from Ben, if ChatGPT doesn't update, does that mean it can't fully process today's information?
So yes, all large language models have cutoff dates. So depending on the model you're using, so GPT-4 is September 2021. I think GPT 3.5 is April 2021. But either way, there's a cutoff date, and it won't know today's world. Importantly, and I guess I should have talked about this potentially when we were talking about the data, there is a misconception that it has consumed all of the internet. Large language models have not consumed all of the internet. Common Crawl, I think, has something like 2% of the internet within its data, and that's obviously been cleaned, filtered by Google. So we see a real subsection of what's in the world.
Okay, and to that point, which leads us on nicely, do we know what AI tools do with the data we give them? For example, the Greenpeace example that you shared, Andy, where they've input all their fundraising history, what's going to be done with that data once the AI tool has it?
Yeah, so actually that example wasn't directly using large language models. That was in partnership with a company called Dataro. I'm literally just responding to that comment as we speak. But again, we do have to be careful about the data that we're obviously inputting into this model. But as Ed's mentioned previously, it's not necessarily actively learning from the data that we're giving, but it doesn't mean that there isn't risk associated with that.
Yeah, so I guess to expand on that, OpenAI realizes how big a risk it is to their business model if people don't feel safe sharing information. So they introduced a few new capabilities about 6 weeks ago where you can erase your history. You can make sure that your data isn't ever used in their training data. You have to actively untick it. It's a bit cheeky like that, much in the same way that Google will, always use your data to improve their services unless you actively remove yourself from it. We can share it potentially in the email. OpenAI talk a lot in their trust center about the various ways that they're making sure that they retain data integrity. But ultimately, it's something that needs to be considered case by case, organization by organization, as part of why strategy and governance is so important when engaging with large language models.
Okay, and can charities actually be involved in the training of AI to avoid biases?
Good question, and not sure it's for us to answer. So Anthropic have been pretty vocal about how they're trying to shape their large language models in a human-centered aligned way, and certainly that's why they've taken in a lot of funding. I'm not aware, though Andy might be, whether they're working directly with any nonprofit organizations over there in the States. I think that they're working with lots of academia, but not actual charities.
Yeah, as far as I know, they're not working with nonprofits directly, but I'm sure by contacting them, they potentially be interested.
Okay, cool. Right, we've got 1 minute. Let's try and squeeze 2 more in. So you touched on a few of the different tools. What are your thoughts about the paid tools such as ChatGPT Plus, and what tools would you recommend for organizations on a limited budget?
Yeah, the capabilities of GPT-4, which you get access to through ChatGPT Plus, or you could use the API as well, but it's easier to use GPT Plus. It's worth the $20 a month, I think. Yeah, in terms of capabilities, heads and shoulders above anything else on the market at the moment, and that includes Anthropic's Claude.
Cool, yeah, I've been using it a lot recently and it is very useful. And then finally, any questions that I've missed, I will follow up with you after as well. What's the #1 way charities should think of using AI? Is that too big for a final one? #1. Fundraising.
#1. Well, Andy talked about it around engaging. I think at the moment, the only thing that you take away from this is to go and have a conversation with a large language model. I think that there's value in doing that. I mean, and explicitly try and solve a problem with it. But that's not the #1 way. But
I think there's so many problems that we see this being able to solve. It's going to be really personalized to each and every non-profit, right? But yeah, I agree. I think there's lots of opportunities in this space.
Brilliant. Okay, well, we're at time. So thank you so much, everybody, for coming. I will read back through the chat and see if there's anything we've missed, and just send me an email when you get the follow-up as well if you've got any other questions that we've left unanswered. So thank you very much to Ed and Andy for hosting. I know you've put a huge amount of work into it as well. And thanks everybody for coming.
Thanks so much everyone for coming. It was
Thank you.
Awesome.